Welcome once again to BC Calculus. This time we're doing parametrizations. We're doing number 16 from section 4.8. So we have to write a parametrization for a circle of radius 3 centered at the origin and traced out clockwise, which looks rather like that. So we have a radius of 3 beginning at the origin, and it is traced clockwise, so going this way. So first, we know that cosine squared t plus sine squared t equals 1. Now we're going to write a regular equation for this circle using x's and y's. So x squared plus y squared equals 9 because this is r squared and r is 3. However, we want to make this 9 turn into a 1, so we're going to divide through by 9. So 1/9 x squared plus 1/9 y squared equals 1. Now that we have something that looks a little more like this equation, we can make cosine squared t equal 1/9 x squared and sine squared t equal 1/9 y squared. Now we want to solve for x and y. X squared equals 9 cosine squared t. So x equals plus or minus the square root of 9 cosine squared t. And y then will equal plus or minus the square root of 9 sine squared t. So this means that x equals plus or minus 3 cosine t, and y equals plus or minus 3 sine t. Now we have to figure out if we're using plus or minus for both x and y. We know that we want to be tracing our circle in a clockwise direction. So first what we'll do is we'll plug in t equals 0 to get a sort of starting point. So let's pretend that we're using positive cosine and negative sine. So if we are, then x equals 3 and y equals 0 when t equals 0. So we start out at the point 3, 0, which is here. And then to get a second point to test which way we're tracing the circle, we will take t equals pi over 2, at which point x equals 0 and y equals negative 3. So we have the point 0, negative 3, which is here. So we know that we're tracing it like this, which is the correct way. So therefore, it must be positive cosine and negative sine. So we write it as the vector xy equals 3 cosine t, comma, negative 3 sine